Okay, so what we're going to look at is proving whether something is a linear transformation or not. And this is a bit easier because we're proving that it's not a linear transformation. So let's look at this. Show that t of 0 goes to 0. So show that, that's number one. We're going to show that t of 0 goes to 0. Show that a scalar multiple of -1, you can just take the minus out. But we also want to show that this transformation is not linear. So we're going from R3 to R2, and the transformation is given by x1, x2, x3 becomes x1 plus 3 times x2, and x3 just becomes x3 cubed. So basically the first one showed t0 becomes 0. In other words, what happens to 0, 0, 0? The origin. Well, when we add this transformation or put this transformation in, you get 0 plus 3 times 0, so that becomes 0. And down here you get 0 cubed, which is just 0. So show that t0 equals 0, done. Show that t of minus x equals minus, and that should be minus t of x. So in other words, we can take a scalar multiple out, minus t of x. Okay, so minus x is going to be, we're going to look at minus x1, minus x2, minus x3, which if we just use this transformation, it's going to be minus x1 plus minus 3x2 and minus x3 all cubed. So that's all the transformation becomes, which in this case up the top is minus outside of x1 plus 3x2, and down the bottom minus x cubed is just minus outside of x cubed, x3 cubed. So, and it's fairly obvious that we can take this minus out. Minus outside of x1 plus 3x2, x cubed, x3 cubed, which is exactly what we wanted to show, that the minus of the transformation of the minus x equals minus the transformation of x. So it's minus the transformation of x. The only other thing we want to show is, let's show that it is not linear. Now, as we've been saying all along, to show something is not is always easy, because all we need to do is find one thing that it doesn't work. Now remember, there's two ways we can show something is not linear. We can show that t of x plus y does not equal t of x plus t of y, and that's the one I'm going to use here. Let's look at t of 8 or t of 4 plus 3. Let's say t of 7 then, and let's see if that and let's see what happens to that. And we'll just, well, I'm only really looking at the bottom one, but let's 4 plus 3, 4 plus 3, all the way down 4 plus 3. What does the transformation of this look like? Well, the top just becomes, this is really the transformation of 7, 7, 7, 7, which the top is going to be, after we put the transformation, it is going to be 7 plus 3 times 7 is 28. And 7 cubed, which is, I should have thought of that beforehand and not used such a big number, 63, carry the 6, 28, 343. I don't need to calculate. 343. Now we can look at t of 4, 444, plus t of 3. I hate it when you do it all wrong like that. T of 444, this is obviously going to be 4 plus 4. 4 plus 3 lots of 4, which is 16, and 4 cubed, which is 64, plus, when it's 3 here, we get 3 plus 3 lots of 3, so 3 plus 3 lots of 3 is 12, and 3 cubed becomes 27. So the top part works. 16 plus 12 is 28. But obviously 64 plus 27 needs to be 343 for this to be a linear transformation, because t of x plus y is 28, 343, but t of 4 plus t of 3 is not that. It's no, what is it, 91. Okay, so that's how you prove something is not a linear transformation, because this does not equal that. We can have a look at another one. Prove that this is not a linear transformation. Prove that it's not a linear transformation. Again, we could look at the x cubed because it's going to fall with x cubed, but we could also look at this. So if we just look at very, very simple, we could look at 0, 0, 2. 0, 0, 2 is going to be 0. After the transformation, it's going to be 0 plus 0 and obviously 4. But if we look at t of 0, 0, 1 plus the transformation of 0, 0, 1, the top's going to work fine. This is going to be 0, 0, 4 plus 0, 0, 4, which equals 0, 0, 8. And again, that's not a linear transformation, because you want t of this to equal t of that plus that. And we could have used any numbers up the top, and we could use any numbers here, but we just have to find one that, to prove that it's not, you just have to find one where it doesn't work. Okay, that's linear transformations. Thanks.